Okay, this is going to be a little video on all of the methods of calculating out resistance in a parallel circuit. So we're going to start with a reciprocal method, and these are in no particular order. And I have gone ahead and done the math, so it shouldn't take very long and we can get through this fairly quickly. So with the reciprocal method on this, and I don't know if you can make sure you can see it clearly, but my resistances are 60 ohms, 10 ohms, 30 ohms, and 100 ohms in this circuit. And we're going to use the same circuit for 3 of the 4 methods that we're going to demonstrate. So the first one is going to be, in the reciprocal method, is going to be 1 over each of the values. And remember that these are added and then we use them to find their final answer. All right, so then 1 over 60, 10, 30 ohms, and 100 ohms. All right, and I've gone ahead and, like I said, and done the math. So this is 1 then becomes, and if we do the math out, each of these, and I'll kind of give you an idea what we're doing when we look at decimal plates. 0.01666 repeating, so I've rounded that up to 1 decimal point 0167, 4 decimal places. So then plus 1 divided by 10 is 0.1, plus 1 divided by 30 is 0.033 repeating, and we can go, same thing, we'll go 4 decimal places. And then the last one, 1 divided by 100 is 0.01. All right, we add those all up. We get 1 over 0.16003. All right, we do that last bit of math and finish this out. My resistance total is going to equal 6.24 ohms. All right, so that is the method in which you do it. So we take the 1 over 1 over each individual resistance. We divide them in to get these numbers. We add these numbers up to get to here, and then we take this number and divide it back into our 1, and we end up with that answer. All right, so as I said, all we're going to do now is we're going to leave that and we're going to go through and show you a different method. All right, so we'll take all of this off. All right, and remember that with the reciprocal method, what our final answer was 6.24 ohms. All right. Now for the next one, let's do just a simple current flow. All right. So with this now, essentially what I'm going to calculate, I'm going to take this out of my thing, right, and I'm going to draw an amp meter in each branch or leg of my circuit. All right, so what we're going to do is we're going to use Kirchhoff's law to help us figure this out. We know that whatever current is coming out of here will be divided equally based on the resistance, or we can use all of the current then divided by 12 to get my total resistance of this circuit. So we end up with 12 volts divided by 60, 12 volts, I'm going to draw in the things, divided by 10 ohms, 12 volts divided by 30 ohms, and 12 volts divided by 100 ohms. All right, so if we do each of these and solve them out, we end up with a current flow out of here, which would be 0.2, 1.2 amps, 0.4 amps, and that should be 12 volts, 0.12 amps. All right. So now what we're going to do is we're going to add all of these amperages from the individual legs up, and what we are going to end up with is a total amperage of 1.92 amps. All right. Simple math now to find out total resistance equals 12 volts divided by 1.92 amps, and our current flow method is going to give us an answer of 6.25 ohms. All right, now you can see we're 1/100th of an ohm difference here, and that is because in my first calculation, what I did was I only went to 4 decimal places. If I had gone to 8 decimal places, we would end up with a much different reading. All right? Or I shouldn't say a much different reading. What I should say is we'd end up with a final answer that is actually going to be closer to the 1.25 or 1.24, right? So we're only talking 100th of an ohm. All right? So the last method we're going to do, and I'm going to clean this up again, is we are going to use, sorry, we're going to get rid of these. We don't need these anymore. We'll fix our circuit back up to this. All right. And the next one we're going to do is product over sum. All right. Now, looking at my circuit here, I have 4 branches or 4 legs that are all different. All right. So in order to just keep this and make the math, I want to have as little math as possible. I'm going to put these 2 branches and these 2 branches together and do the math for them individually. All right. So I have to get my other. All right. So what we end up with then is product over sum for the first half is 60 times 10 over 60 plus 10. All right, and then on the other half of it, we are going to have 30 times 100 over 30 plus 100. All right, so we can do each of these out, and what we're going to find is then the next step of this would bring this to 600 over 70, and this one would be 3,000 over 130. All right, now what I've done with this one is actually left, I think we're down to 2, 4, 6, 7 decimal places on this, and then we'll do the math and we'll include all of the decimal places, and I just want to do that to show you what difference we are going to get if we have that many decimal places. So if we do this, we end up with a resistance of these 2 legs at being 8.5714,285, and if we do this one, we end up with 223.076923. All right. So if we look so far, we're going down to here, and we've kept them split. But now we ended up with what we've done is we've calculated these 2 resistances into one, and these 2 resistances into one, but we still do not have a single resistance. So we use these numbers, and we simply do product over sum again. All right, so it's 8.5714,285 plus 23.076923. All right, a lot more numbers, a lot more math. We're actually going to figure that out. So that's 197.80219 over 31.650658. All right, so we're getting this down. So when we do this, we are going to end up with our resistance total, because we have boiled this down now until our final answer. And our final answer, and I'm going to put it over here, just because we're using, this is product over sum, and this we come out with an answer of 6.2495443. All right. So taking a look at these, all these three numbers, we essentially came out with basically the same answer in all three cases. It does not matter which style or method you use, you are going to get the same answer. And if you look at this, right, we got the current flow at 6 1/4, right, and I said on the first one that I did not use all the decimal places and we were 1/100 short. But look at this one. We are actually only 5/10,000ths of an ohm less than this value. All right, so if we round this up, this becomes this, and this comes up to here. We end up, by rounding that up to 2 decimal places, at being 6.25 ohms. All answers are exactly the same. It does not matter on the method that you use. Okay, so we're going to change it up now. Those three, we did the three different methods, and we came out with all the same answer. All right, so we're going to get rid of this, and we're going to show you one other method that we had talked about in theory, and that was when resistors are of equal value. So I'm going to change the values on these. I'm going to get rid of this line and this line. Get rid of this here, 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 here. Now we're going to add some more resistors to this. All right. Hopefully that's clear enough for everybody. I'm going to get rid of that one too. All right. So currently we have 4 resistors in that circuit. We're going to add 4 more. All right. Now, get my cheat. All right. So these ones, we're going to go 30 ohms on each of them. 30, 30, 30, 30, 1, 2, 3, 4, 5. Oh, we need one more resistor. 30. 1, 2, 3, 4, 5, 6 30s and 2 at 12. All right. So with this method, and this is resistors with equal value. All right, we take the value of, right, 30, 30, 30, 30, 30, 30, all the same. We take the value of the resistor, and let's write it out so we know what we're doing. And we divide that by the number of resistors that value. All right? All right? So 30, 30, 30, 30, 30, all the same. 1, 2, 3, 4, 5, 6. All right? So we know that we have 6 resistors. The value is 30 ohms. The number is 6. All right? We take this, divide it by 6. Total resistance of all of these resistors. I should put total. Of 6 equals 5 ohms. All right? 30 divided by 6 equals 5. All right? Now we have 2 resistors that on the end that are different. They are not 30 and they are not 5. And so we have to treat them as a separate thing. But because they are the same, now we could do product over sum, right? 12 times 12 is 144 divided by 12 plus 12 is 4, which is going to give me the same answer. So we can use this, we'll go this way. 12 ohms, which is the value of those resistors, divided by the number of those resistors, right, equals 6 ohms. Now, the first part of my equation was 5, the second part of my equation is 6. Now I know that if I took all of these resistors, they're essentially equal to one resistor of 5 ohms. And if I take these two resistors, I know that they are equal to 6 ohms. All right? Now I can use, which method do you think would be great? I'm hoping you're saying product over sum. So we can take 5 times 6 over 5 plus 6 equals 30 divided by 11, which equals 2.7272727 forever. All right? So that is a way to calculate resistance when they are of equal value. And now whether the circuit is all the same, you could have 10 lights that are all the same value, and you could do the resistance of one resistor and divide it by the number of resistors, 10. Okay? And that's it.